Hello, this video will show you a walk through the breadth first search algorithm. The breadth first search algorithm is a way to traverse a graph in such a way that we're going to visit first the vertices that are closest to a starting vertex and only then move to the next further level away from the starting vertex and then visit the next ones. So for example, if we're at letter A, we're going to visit B, C, D, and E first, and then we're going to go and visit letters F and G, and then we're going to visit letters A, H, and I. So that is the breadth first search algorithm, and it is used to determine the shortest possible path between different locations on a map, for example. The rules that we need to follow in order to implement this algorithm are a couple. And the first rule is we're going to try to visit the next unvisited vertex that is adjacent to the current vertex, mark it, and insert it into a queue. So if we are at letter A, we're going to visit letters B, C, D, and E and mark each of them as visited and put them on a queue. So you can see the queue in table 13.4. After we visit E, we have B, C, D, and E. So at that point, we have visited all of the letters that are adjacent to A, and we can no longer follow rule 1. At that point, we have to go to rule 2, which is if you can't carry rule 1, then you have to remove the vertex from the queue and make it the current index. So the beginning of the queue is B. We're going to remove B from the queue, and now we're going to try to follow rule 1 again. And following rule 1 means that we're going to visit F, mark it as visited, and we're also going to put it at the end of the queue. So now the queue is C, D, E, F after we visit the F. After we're done with F, we can no longer follow rule 1. We're going to go to rule 2, and we're going to remove C from the queue. When remove C from the queue, C becomes our current index, and the queue that we have is DEF. There's nothing to visit from C, so now we're going to remove the next thing from the queue, which is the D. Once we're at D, we can go back to rule 1, and rule 1 says that we're going to visit G, mark it as visited, and put it at the end of the queue. We have the queue. Once we visit G, we have a queue as EFG. Then we're going to go and remove E from the queue because we can no longer follow rule 1. We're going to go to rule 2, right? We're going to remove E from the queue, and now E becomes our current index. E you cannot follow rule 1 and E, so now we're going to go back again and remove F from the queue, and then from F we can now visit H. So what we're going to do is once you remove F, right, then you can visit H and your queue becomes GH, and it's so on and so on and so on. So once we follow these rules, we're going to be able to traverse this loop by levels, basically, right? So how is this done? With a little more detail in Java. So you have the Java code from the book Clav4, which is what we're using for our class. And in there, we have our breadth first search algorithm. The first part is showing you a queue, right, which you have already had to do as part of one of your weekly assignments. So you will know how to use a queue by now. And it's the same exact queue that you had to create. So nothing new, nothing fancier. Okay. Now what we're going to add is we're going to add a class called Vertex. That class is going to have a character variable to keep a letter and a Boolean variable to keep track of whether that vertex was visited or not. And the constructor allows us to set those initially to visited as false, and we're going to set the letter to whatever the user wants. Okay, and here in our main, we're going to give these, first of all, our graph class creates an array of vertices, and in our main, we're going to give these vertices names. Okay, so we're going to give each of these arrays of vertices a new name using the add vertex method, which you can see here, which also uses the constructor. And so we basically create an array of objects which have letters in them. And then the next thing to do is to try to figure out how we're going to create this kind of a picture here. So if I wanted to have a graph where A is connected to B and D, as you can see here below, then what I have to do is I have to create some kind of a two-dimensional matrix, a two-dimensional array, which will basically hold a spreadsheet here. And I'm going to put the letters A through E on the top, A through E on the side, and then wherever the letter A is adjacent to a certain other letter, we're going to put a 1. So A is adjacent to B, and it's adjacent to D. So we're going to put 1s there. B is adjacent to A, and it's also adjacent to C. Okay, so the way we're going to do this is we're only need to do this one time. So if I wanted to do a relationship between A and B, right? So A and B are going to be adjacent. I am going to call this code right here, 0, 1, at edge 0, 1, which calls this function here, and is going to create this relationship using the 0 and 1. So we're going to put a 1 and a 1 here. Okay? And then if I wanted to do this again for letters B and C, then I say add edge 1 and 2. And that now creates the following relationship, which basically puts these two green ones in the middle, and so on, until we create our relationship matrix. So we have two things. We have our array of vertices, which has a letter and a marker to tell you whether it's true or false, right? Whether it's been visited. And we have a two-dimensional array adjacency matrix, which is part of our graph, to hold the relationship of how these different vertices are connected to each other. All right, so now that we have this set up, now have a look at our breadth first search algorithm. Okay, and the breadth first search algorithm is going to use a queue, and here's a little picture of a queue in case you forgot what a queue is, right? The first person who visits is all the way at the front, and the last person who came at the end of the line is all the way at the rear, right? So the person who's at the beginning is going to leave first, and people who come will come and line themselves up at the end of the queue. So that's the queue. Now let's have a look at how we're going to use it into the breadth first search algorithm. So first of all, the very first thing we're going to do is we're going to the root, or the first vertex, right, which is the A, and we're going to mark it. So we're going to make that equal to true. We're going to show it using the display vertex function, and we're going to insert it on our actual queue, right? And this is your insert function in the queue, which basically moves my originally we're starting with an empty queue. When you're adding your first index, the index 0 for the vertex 8, right? You're going to store that here in the queue, and that is going to move your rear to forward 1, and now this is your front and rear with one element in the queue. Okay, now the next thing we're going to do is we're going to go into our loop that you see underneath here, and we're going to keep going in this loop until the queue is empty. As soon as the queue is empty, we have basically shown the entire graph by level, which is the breadth first search. So the first thing we're going to do is we're going to remove an element from the queue, right? So the element was here, and as soon as I remove that, our front is going to move forward, right? And I'm going to store the value that is here into my temp variable, which is what the variable v here is going to be equal to. So v is equal to 0. We're going to send the 0 here into my get adjacent unvisited vertex method, right? So this receives a v equal of 0, which means that we're going to be looking at the first row of this adjacency matrix. Okay, so we're going to be looking at ADJ MAT 0, 0, 0, 1, etc., 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 and try to find one that is equal to 1. As soon as we find one that is equal to 1, we're also going to check to see if that one that we're looking at was visited or not, right? So in other words, we're at the A, we're looking at B, right? And B was not visited, so that is our first hit. So that means now we're going to grab this index, the J, and we're going to return it back to where this was called. So now V2 is equal to 1. Once this V2 is equal to 1, we're going to mark the vertex array with index 1 to true. We're going to show vertex 1, which is the B, right? We're going to show B. Then we're going to go and we're going to insert this index into our queue. And what's going to happen is we're going to change our queue from what it used to be here to, we're going to move the rear forward, and we're going to make this element of the queue array equal to 1, which is the index of the letter B. Okay, and now what we're going to do is we're going to go and do this again. And by the way, one thing you can notice is that this inner loop right here, where we have while and v2 equals, right? What this is actually doing is traversing the rows of this adjacency matrix, right? So we're now looking at, we're telling it go, keep going. This one's already visited. Okay, this one is a 0. Okay, we got another one, right? So what this in essence is doing is it's, if you're looking at the picture, it's going and it's checking for any other letter that is connected with A very easily by just going through the row, right? And that's the purpose of this inner loop that we're having here. Okay, so we're going to pull the next J for, or the next index for the letter that is adjacent, which in this case J is going to be equal to 3, where we have a 1, and this is not, hasn't been visited yet, right? So since this was visited, we're not going to look at that. This one was not visited, and now this is my 3, index 3. Okay, so now what we're going to do is, now we're getting the index 3, we're going to return it, bring it back here. We're going to mark vertex 3, which is the D, as true. We're going to show the D. So now you can see that we have already shown B, right? And we showed A, so B, A, B, and D. So now we showed A, B, D. So we're following the breadth first search pattern that we saw earlier. And so after I show it, I'm going to insert it into the queue. So now I'm getting the 3 and I'm inserting it into the queue, which is going to move my rear forward, right? So it was this, and now it's going to change to this. Okay, so that's the queue of indexes that I have in here. And now I keep going. So I'm still fixated on this row, and on this row you can see that there's no more unvisited ones, which means that at this point now we're going to return a -1. Okay, so since we don't have any more unvisited links here, we don't have any more unvisited letters, so basically we visited the B and the D, and we're going to return a -1 to here, and that's going to stop the loop. So we're still left with the same queue that we had from before. Now, since the inner loop stopped, now we're going to go and we're going to remove from the queue. What are we going to remove from the queue? Well, when we remove it from the queue, right, we're going to get this element, the 1, we're going to store it into temp, and then we're going to move the front forward. Okay, so now v1 is equal to 1. Okay, so v1 equals 1 at this point. And we're going to go inside the loop. We're going to call get adjacent unvisited vertex 1, right? That means that now we're going to be looking at this row, right? When v is equal to 1. And when v is equal to 1, we're going to basically look at, 1, 1, 0, right? Is this one a 1? Well, yes, it is. But if you look at j of 0, right? That was already visited, so we're not going to count that. Then we go down, right? This is a 0. We're going to go to 1, 2, right? This is ADJ MAT 1, 2 now, right? Which is equal to 1, and it has not been visited when j is equal to 2, right? Still false. And then that means that that's the one we're going to return, and we're going to return a j of 2, right? We're returning the j of 2. Now what we're going to do is we're going to mark that as true, right? So now the C has been visited. We're going to show the C, which is what we just changed, right? We're going to show the C, and we're going to insert that index of 2 into my queue. So now the 2 is going to go here, and I'm going to move my rear again forward, right? So it used to be this, then it changed to this, and now it has changed to this. Okay, so that's where the 2 goes in the queue. This is my front, this is my rear, and of course these are indexes. These are the elements, right? And so on. So the next thing is we're gonna remove from the queue. When we remove from the queue, what we're going to do is we're going to move the front forward, right? We're going to store whatever was in the front into my variable temp, and we're going to return that, right? So we're going to return 3, and in here v1 is going to be equal to 3. Okay, now we're going to call the function get adjacent unvisited vertex with 3, right? So here v is going to be equal to 3. Okay, and we're going to look now for the v of 3 row, right? And since we have already visited the A, right, j0 does not count. The only one that hasn't been visited is the last one, which is j is equal to 4, and that is the one that we're going to return. We're going to return it, right? J of 4, we're going to mark that as true. So now we have visited the E, which is the last letter. We're going to insert it in the queue, and at this point the rear is going to move forward. Okay, and that is my index 4 that I'm going to store in there. Okay, and at this point what happens is we have visited all of the letters. So what will continue happening at this point is this loop here, the inner loop, right, is going to continue to return -1, -1, -1, because we can't find any more adjacent to anything, right? And what's going to happen is we're going to empty up the queue that we have here, and once the queue is empty, the depth first search algorithm is ended. But that is in as much detail as possible your depth first search algorithm explained, and I will post this video and the spreadsheet on the class webpage. Please let me know if you have any questions. Send me your emails.